Hi everyone, this is Jayashree, Assistant Professor, Department of Triple E. So, we are in continuation with this lecture series. Today we discuss upon some of the parameters in AC waveform. So, AC, we all know it is nothing but it is alternating current. That is both the polarities, the voltage and current is changing from positive to polarity to negative polarity. You all know the Indian system, the frequency is 50 hertz. The AC voltage, it attains positive maximum to the zero, then it comes to negative maximum uh, 50 times in a second. So that is the frequency. It attains 50 times zero within a second. Okay, right. In that case, how to calculate the value at a particular instant? So, to calculate the average voltage, the voltage at a particular instant, we need some of the parameters. So, here we have listed some parameters. First one is instantaneous value, second one is peak value, third one is average value, fourth one is RMS value. Okay, right. So, what is instantaneous value? If we take a sinusoidal waveform, the voltage is changing. See in this graph, the voltage starts from zero, it attains maximum, it comes to zero, and attains negative maximum, and again comes to zero. Okay, every 50 every second, it attains 50 times. Right. So instantaneous value is nothing but the value of voltage or current, that is AC quantity, at a particular instant, at this period, in this time, at this period. So what will be the voltage? That voltage, that is value of voltage at particular instant, we call it as instantaneous voltage. Right. Then what is average voltage? So that is the area under the curve, we call it as average voltage. Right. So to calculate the average voltage, we have to take the area under the curve using integral form. Using integration, we do that. Right. So average value is the average of all particular intervals. Okay. Total area divided with time period gives the average value. Okay. Then next one is peak value. So the peak value is nothing but the maximum voltage at there is either it is maximum voltage in the positive polarity, otherwise the maximum voltage in the negative polarity. That voltage we call it as peak voltage. Right. The next one is RMS voltage. What is that RMS? RMS quantity, that is root mean square component. Right. So square root of mean is average of squares of voltage or current. Okay, so it is square root of v1 squared, v2 squared, v2 v3 squared up to vn squared. If we divide a waveform in n number of intervals, so we have to make a square and add, okay, sum of squares, and we have to make it average, and we have to take a square root. Okay, the RMS value of a set of values is the square root of arithmetic mean of the squares of the original values. This is RMS value of a AC waveform. Okay, right. Then we discuss upon power. So what is power? Generally, rate of doing what we call it as a power. In DC component, it is the product of voltage and current. But in AC component, we have to consider the phase angle also. So always based on the circuit elements, if in pure resistive circuit, there is the voltage current are in line with each other. Whereas in inductive circuits, if the circuit contain more inductive components. When the current is lagging behind the voltage, the circuit contains more capacitive components. Current is leading the voltage, okay, by some angle, for example, 20 degree, 30 degree, 32 degree, okay. In capacitive circuits, current is leading. In that case, what is the formula of power? Okay, the formula of power is V into I into cos phi. That cos phi we call it as a power factor. Okay, so in if you take an AC component, there are the active power is VI cos phi, right? Then there is another component we call it as reactive power due to reactive elements in the circuit, right? Then there is average. That is next one is apparent power. This volt into current. Volt amperes we call that as volt amperes. We'll discuss that elaborately in the next session. Thank you. Thanks for watching.